also fine. So in this lesson, guys, I will be touching on the parabola function. So the moment, guys, you see x2 from the equation, just know that equation there, it represents what? A parabola. If you see x2, that equation, it represents a parabola. And in order for you guys to draw a parabola, you should get a what? A turning point. And you should also get the what? The y intersects. And also the x intersects. Meaning that you should get the values where it will intersect the y value, and you should get the values where it will intersect the x value. And you should understand something, guys. In order for you to get the what? The y intersect, you should just let x there to be 0. And in order for you to get the x intersect, you should let y there to be 0. Do you see? Then you solve what you're supposed to solve. So all of this information, guys, you will understand as I will be drawing the graph with you. And this, guys, it's a shape of a what? Of a parabola then. It is the shape for the parabola. A parabola, guys, it can be in two shapes. It's either it can be a smiling shape, or it can be in a set face there. Set shape there. Do you see this thing? If your graph is like this, if your graph is like that, then this is what you call a what? A smiling face. But if the graph is like this is what you call a what? A set face. And in order this thing, guys, to be a smiling face, the gradient there must be positive. But in order for it to be a set face, the gradient there must be negative. Do you see? And now you should understand something, guys. We will also have what to call axis of symmetry. Axis of symmetry, guys, will be the dotted line that will divide the parabola into two equal parts. It will be a dotted line that divides a shape into two equal parts there, axis of symmetry. So it will divide it here so that it will have two equal parts, and it can even divide it here so that it can have two equal parts there. Do you see this thing? Yeah. So let's go, guys, to the equations then. So we got these equations there. There are three equations that you should know. We got a standard form equation. A standard form equation, guys, this our A there represent a gradient. As you know, our A represent a gradient. This thing there is a standard form equation. And something which is in a position of C, it will be representing our y-intercept there. Do you see? It will be representing our y-intercept. So in order for you to get the what? The axis of symmetry, if they give you a what? A standard form. This is the equation that you should use them. You should just use this equation so that you will get what you call axis of symmetry. Axis of symmetry at the dotted line that divides a shape into two equal parts. Don't forget that one. Axis of symmetry. So we'll be using this equation then. Do you see? Yeah. Then what about for this equation, guys? Let me tell you something. So if you want to get a turning point, you will use this thing then to get your input as an x value. Then you will use that equation to get your output there. Do you see? As your y value there for a turning point. But some other learners, guys, they even forgot this equation then. Some other learners, they even forgot that equation. If, guys, you feel like it's hard for you to know this equation, what you can do, you can even use this equation there, the one of what? Of axis of symmetry, to get your turning point there. I can use this equation, guys. That equation there, it will give me my input there. It will give me my input, that equation. Once I know my input there will be the what? Will be the x value there. Once I know my input, I will substitute to the original equation there, so that I will know the what? The output there. Meaning I will know the what? The y value there. If I substitute the input, I will be able to get my output, guys, as a y value there. Do you see? Without even using that equation there. If you can know your input, you'll substitute in that equation so that you will know your output. Then you can identify your turning point there. Do you see? So a key thing, guys, that I need you to understand, guys, about the standard form equation. What you should understand, this equation, we will usually apply it if we'll be having our y-intercept them. If we got our y-intercept, we'll be using that equation there. If we got the y-intercept, it's good for us to know this equation if we know the y-intercept. Do you see? Going down, guys, here we got what you call a turning point form. A turning point form, guys, it's easy for us to get a turning point if we got equation like this there. Do you see this thing? If we got equation like this, it's easy for us to get a turning point. Remember, this A there, it represents a gradient, and a gradient is the one that changes the shape of a parabola. If it's positive, it will be a smiling face, but if it is negative, it will be a sad face. Do you see? Yeah. So in this case there, you can tell this thing there, this is a smiling face, meaning that A there, it's positive at this case there. So let me explain, guys, this equation. This equation, guys, it's easy to get a turning point there. For you to find a turning point in this equation, what you will do, you just hide all of this part there. Do you see the part that I just hide? It means that y is equal to q there. Y is equal to q. That thing there tells me that the y value of a turning point, it will be q there. The y value will be q there. If I hide all this part, y value will be equal to q for the turning point there. But now when it comes to the x value, we'll be having some kind of things there, because this is what we'll do for the x value. We'll just do this there. Do you notice that something which is associated with x there, it's p? If I hide this part, all the part that I hide, do you see that x plus p there, those two things there, something which is associated with x, guys, it's p. And you should understand, guys, something which is associated with x, in order for you to put it as a turning point, it will change the sign there. If it's positive, it becomes as negative there. Then if it was negative, it was going to become as positive there. Do you see? Something which is associated with x, it will only change the sign there. Do you see? In order for us to get the x value of a turning point, we'll take something which is in a position of p there, but we'll only change the sign there. Do you see? That's how, guys, you get a turning point. And this equation, guys, we'll only use it if we got a turning point. If we got a turning point, we can use this equation. That one is so important, guys, to know it. Then for you to get the axis of symmetry, you can just take that thing there, something which is associated with x, you equate it by 0, then you solve for x there, take that thing to that other side, then 0 will disappear, and that p will become as negative p, meaning that axis of symmetry will be represented by x there, which is equal to p there. If there you got positive p, it will become as negative p there. Something which is here, guys, it represents your axis of symmetry. Please know that one. And axis of symmetry, they will divide that shape into into two equal parts there. Do you see? And these are the axes of symmetry, and they will pass through the x values there here. Do you see? And they will be represented this equation. So please, guys, know the turning point form. So let's go to the x-intersect form. X-intersect form, guys, that equation, it is in a form like this there. Do you see this thing? This equation, guys, we only use it if we got the x-intersects. These are the x-intersects. The graph, it intersects the x values there. It intersects them here and there. Do you see? So if it intersect twice, we'll be having x1 and x2. And a key thing, guys, that you should understand, if you got x1 and x2, you will take those points, substitute them here. Do you see this thing? You will take those points and substitute them here. Please, guys, take a note about that one. And for you to get the axis of symmetry, this one there is your graph. What do? You just add both of those two values, then you divide that by 2, so that you will get the axis of symmetry. That dotted line which divide a shape into 2 equal parts. Please, guys, take note about that. But maths, guys, can trick you. Maths, they cannot give you the graph. They can only give you the equation. If they give you the equation like this, you want to get the axis of symmetry, you know that this is the equation that you should use. For you to use that equation, you will take x1, come and put it there. But something, guys, which is associated with x, it should change the sign there. If it's negative, you come here and substitute that being positive. Then if there it's negative, come and substitute that being positive there. Then you divide it by 2. But if it was positive there, you will come then substitute there being negative there. But let me not go deep down there, guys. The only thing that you should understand there, if there it's negative, it's supposed to be positive. If there it's negative, it's supposed to be positive there. Only if they give you the equation, then you just divide by 2 to get the axis of symmetry. But if they give you a graph, you can just take those values, then you add them, you divide by 2 to get the axis of symmetry. But now, guys, you know maths, it got some tricky parts. Maths, what it will do, instead of the graph touches twice, the graph, it can just touches once there. If the graph there, guys, it touches once, that equation now will become like this, guys. That 2 now will just be here. That equation now will become like this, guys. Do you see this thing? Whereby when it touches once, that point there will only be this one there. Do you see this thing? Just please, guys, take a note about that one. And for you to get the axis of symmetry, axis of symmetry, let me just say axis of symmetry, they will be represented by x1 at this point. Do you see, guys? In this situation, axis of symmetry, they will only be represented by x1, whereby those axes of symmetry are the dotted line that divide a shape into 2 equal parts, and they will all the time, they will be passed there at the x-axis there. Do you see? At the x values there. Do you see? So axis of symmetry will be represented by x value there. As you can see, even as well as here, they will be passing through the x values there. Do you see? So the x-intersect form, guys, you only use it if you got the x values. If the graph, it intersect the x values there. Meaning that if it cuts the x values, those are the x-intersects. Do you see? But now the turning point, you will only use it if you got the turning point there. Do you see this thing? Yeah, if you got a turning point. But now a standard form, you will use it if you got the y-intersect, where the graph cuts the y values. Do you see? So this, guys, it's already a summary of what you should know about this topic there. You should know 3 equations, 1, 2, 3, and know when to use those equations. Do you understand? Yeah. And at the same time, you should be able to draw a graph by finding turning point, y-intersect, and x-intersect them. Do you see? Yeah. So please, guys, take a note, guys, about this thing. These axis of symmetry, they also represent the input, the x value of the turning point. Even as well as here, axis of symmetry, this one, axis of symmetry, they also represent the x value of the turning point, even as well as this one there. These axes of symmetry, they will represent the x value of the turning point, meaning that there will be there will be our input, by the way. So let me not make this video long, this lesson long. So there it was, just a summary, guys. So now I will be diving deep now to the question. Just stay with me for the next session. Thank you guys for your time. All the best and enjoy the lesson of Parabola.